Hi, this is Dr. Carl Goldkamp. If you're interested in learning about the ketogenic diet like I was, to save my own life, then this is probably the podcast for you. 8 years ago, I knew nothing about it. 6 years ago, it saved my life. 3 years ago, I started researching and talking with some of the authorities in the field and attending medical conferences about this to understand why and how keto so dramatically changed my and my wife's Judy's lives. The purpose of this podcast is to share our journey of discoveries with you in understanding how keto is so effective in improving so many different conditions, from obesity, epilepsy, diabetes, infertility, MS, Alzheimer's, heart disease, to name a few. So take a step away from all the hype you've probably heard and roll up your sleeves with me and join me weekly to explore this living miracle that anyone can access. We'll talk science, we'll talk food. We'll explore its history and evolution to today, which is that the sheer wonder of the ketogenic way of eating has changed untold number of lives, unlike anything before it. And in case I forget to mention it, please join our Facebook group, Keto Naturopath. Hi, this is Dr. Goldkamp, and welcome back to another episode of the Keto Naturopath. I wanted to pick up where I left off last time. We talked about depression, we talked about suicidal ideation, we talked about underlying causes that I believe are fairly easily treatable, easily changed with subtle intervention. So it's not big, strong, armed medication coming into the rescue. It's shifting diet, and it's all around ketones and basically the transformation of ketones to GABA and so on and so forth. So we talked about that. Now I want to go into another layer, and this is very much how I do our program, another layer that needs to be looked at, and that is some genomic irregularities. In other words, certain mutations that are very common in the population. So they're called poly, as in many, morphisms, as in shape. So poly, a common shape or a common mutation, not deadly or anything else. And not every gene has this. These are ones that are, there's a lot of polymorphisms, but there's not a lot of polymorphisms that you can have a hand in making them work better. And so that's the whole thing. So the list of polymorphisms that people have, that they can intervene in a number of ways to make their life better. But today I'm focusing on some genes, we'll see how far we get, with emotional disorders, mental disorders. Things like psychosis, bipolar, schizophrenia, severe depression. And I'm probably missing, did I say bipolar? Okay, bipolar 1 and 2. So this is important, but let me give you a few interesting just titles of studies, because I think that sort of shows you how concrete this information is getting. And I would say that every time we talk about this particular gene or genomic mutations that are problematic that can be treated, you really have to think of Kilmer McCulley, Dr. Kilmer McCulley out of Providence, Rhode Island, and his whole story of being fired for looking into and discovering that actually these, as we get into some genes today, looking into these has a lot more to do with elevated cholesterol and lipid metabolism than did having fats in your diet. So we're going to look at MTHFR, which is methyl tetrahydrofolate reductase. I know it's a mouthful, but you'll get used to it. And you've probably seen this. If you just punch this into Google and go MTHFR in capital letters and depression, and then you can go for another topic, and autism. Another topic would be, keep on going, ADHD, and so on. So here's a study. This is really pretty interesting. So it's MTHFR and psychosis. An epileptic drug induced psychosis associated with MTHFR C67717. That's exactly the mutation that I have and many other people have as well. So I have it. Worst case, homozygous, got it from mom, got it from dad, and it's highly associated with a lot of the conditions I've told you about, autism, dyslexia, and so on and so forth, the spectrum. What is interesting about this is, here we go, various epileptic drugs can potentially cause psychiatric side effects in patients with epilepsy, but they don't really know why that is. So they did of this population who had a bad outcome, that is, had a psychotic event when they were on an anti-epileptic drug, they looked at that population and found, well, actually a number of them had that polymorphism that I have, the MTHFR C677T, was the problem. So what they did was they said, I'll read the whole sentence, a common polymorphism, that one I've just told you about, has attracted attention for its role in onset of psychiatric diseases. So MTHFR and several vitamins, cofactors, are crucial for remethylation of homocysteine. Heard me talk about that before. Also think of Kilmer-McCulley via folate and homocysteine metabolism. So they reported on a Japanese patient who presented with a reversible schizophrenia-like symptoms during an anti-epileptic drug therapy. So basically when they got off the drugs, his schizophrenia went away. So the conclusion was this actually was the first report of an anti-epileptic drug-induced psychosis associated with this particular polymorphism, the MTHFR C677T, and multiple vitamin deficiencies. So just reading that, let's just take that sentence. They associated with this mutation. Therefore, you would think that it would be common medical practice for doctors to be looking for certain mutations, right? Check. And also, and then it said, and multiple vitamin deficiencies. You think the second thing they would look for would be vitamin deficiencies. And vitamin deficiencies isn't something everybody just wears on their skin. You know, it's not just a physical evaluation. It's serum. It's intracellular. So don't you think it would be required to do in the very least serum, which is kind of inappropriate for a lot of nutritional deficiencies, but an intracellular nutrient analysis. So they call that micronutrients, right? All your cofactors are micronutrients. Duh. So I come back to this theme because this is basically what we do. To me, this is how I evolved in medicine and how other people, I believe, who are paying attention evolved in medicine as well. You listen to the patient's story. Check. You see what they're eating. Check. You look at where they lived. In other words, environmental exposures at the best that they can come up with. Tell me about your life, and you give them a little thing. Check. Okay, let's look for nutritional deficiencies. Let's go through and, well, now it's easy to do polymorphisms. Before you had to name that polymorphism, send it into the lab one at a time. And that is hellaciously slow. So now, in the very least, you get some from 23andMe, which everybody's done. But better yet, go to a company that will do a more thorough job and keep that data isolated from everybody else. It's just going to be personal data, and they'll share it with their doctor as a report. Boom. There you go. The fact that we go into hormonal aspects of that, really, I do that for a patient's buy-in. So they can see another venue, another collection of data that relates to these same factors. This is what I think is appropriate medicine. So that's my little soapbox. So now here we go. And this was 2019. So all of August 2019, not even 2 years ago, a year and a half ago. So to have this conversation be presented in this way. So where'd it go? Our findings contribute to the elucidation of the pathogenesis of the psychiatric side effects of the anti-epileptic drug and led to improved medical management for patients with epilepsy. Duh! Don't you think that's appropriate? Why not we look into some of these things and now mark that down? So let's get into a little bit of a larger aspect. So I hope you're going to hear a lot. If you're listening to me, you've heard a lot, and you will hear a lot more, hopefully from other sources as well, about various genomic polymorphisms, otherwise known as SNPs, singular nuclear polymorphisms. Just they're off by one that causes a problem, and there's a variety of those. And so the ones that have to do with, I call the intersection, the topic of remethylating something. So methylation is a detoxification pathway. It happens in your body, all over your body. Like your estrogens. Your estrogen, as you, men and women, as you use your estrogen, they then get detoxified, broken down, and they get methylated so they can go out with the urine. Okay? That's how they leave the body. So other things are that way too. But also, methylation is turning genes on and off. So think of a light switch as you come into a room. If you didn't have the light switch, well, the room is either going to be lit all the time or it's going to be dark all the time. You need to be able to turn it on and off on a per needs basis unless you plan to live in that room for the rest of your life, right? That's pretty much the way it is for, there again, think of hyperactive ADHD, hyperactive attention deficit disorder, or autism, or anybody on that spectrum. And they're on. They're all on. So an autistic kid, if you've seen a number of them, or children, are all on. They almost can't turn off. So that's a light switch that can't turn off. That's a room that is one way or the other. And so you have to figure out where you can intervene to change that light switch, to turn it off. Little oversimplification, but not by too much. So when we look at, now we're talking about methylation as a concept. We want to make sure our methylation is so facile, so quick, so adept, it can instantaneously turn something on and off. So think of now going to that room that has those, laser or motion detectors. So as you go in, turns off. As you go out, turns off. Well, turns on, turns off. And so it's there for as long as you need it. And now that's very precise. So you want methylation to be that way as well. Turns on as well. And so as you go, neurotransmitters are turned on, then turned off. Turned on and then turned off, just exactly as you need them. They don't turn on and stay on and start mixing with other neurotransmitters and becoming a problem where you keep on producing this one set of neurotransmitters. So that's what methylation is, turning genes on and turning genes off. Big deal. So now in this, what I call intersection, this intersection of only a few mutations that people can have will really slow down their ability to methylate anything. So what happens if estrogen isn't methylated appropriately, isn't broken down? Well, too much estrogen, especially estradiol, goes in to be carcinogenic. And in fact, if you were to go on to the NIH list of carcinogenic substances, estrogen is a carcinogenic substance. So inappropriate amount. That's why pretty much anything's a carcinogenic substance and too much, or lethal, I should say. So turning it on and turning it off, the appropriate amount at the appropriate time is what makes a substance become not a problem. If we need it, it does its thing out of the body, or it gets converted into something else that's no longer problematic, carcinogenic, or whatever. So that's an example of that. So in this intersection, in order for us to be able to methylate things, we have words like one genome is called methionine synthase, another one is called cysteine beta synthase, and then the other is MTHFR. These three come together, and not everybody has a problem with any of them. So some people don't have a problem with any of them, so they are great methylators right out of the box. Others, like myself, have a number of these problems, and so that would be a child that would grow up with a number of learning handicaps, a number of learning disabilities that would have to be compensated for. Now that we know enough to look for these things, they can be intervened with nutritional application. So not only the right supplement, but the right types of food, and keeping crap out of their diet is always an assumption when I speak. Don't give them crap like, oh, they can have donuts as long as they have these supplements. No, they can't have donuts for the most part. Okay, so we have these three genes that have to do with this intersection, and that has to do with they call methylation. And so what things need to be methylated? B12 needs to be methylated. Cyanocobalamin needs to be methylated, another word for B12. Folic acid needs to be methylated. So there's some tricks, if you will, that sometimes if you have one of these enzymes, the genes for one of these enzymes is a problem, well, maybe you can just take the supplement for the other side of that gene, so that enzyme. So if an enzyme changes AB into this thing called C, and your enzyme that changes A and B into C works so slowly, well, why don't you just take some C and then you sort of hopped over the problem. And that's what some of the supplements are like. You just take the end product that's ready for the next. When you end up having too many problems, no one thing is going to be the improvement. You have to think a little more complicated, a little more multifactorially. But you look for these things and you can map these out. So the fact that in the average person today, we can get a map of the top 85 most problematic polymorphisms, which are the genes for an enzyme. So the gene is what we're looking at. If it's problematic, it usually means it's slowing it down or speeding it up. So we have to find out which one that is. But now we can actually get a map of that. That's mind-blowing. So the fact that the map is so available now, it really, in my mind, is no excuse at all for any doctor to not say, we're doing this, we're doing this, we're doing this. We put them together, and now we know where some of the biggest problems are about your situation, you being the patient coming in to seeing Doctor Who. And so Doctor Who is going to tell you after that, I got it. These are the things you need to do. These are food sources for these particular things that you need. These are various supplements that's unique to you, or unique to people like you, I should say. And this is how you go forward. And they will give you a larger context of, oh, this is why you've been reacting in a certain way, and so on. So nothing is ever just one thing. So I don't want your whole life to become genes now. I'm going to go out and look for my genetic polymorphisms and take the supplements for each one, because then you're going to go crazy. There's not just 3 or 4. As I said, there's at least 85, and you can go on from there. And people do this. There's a whole cottage industry, as I've said before, to convince you that life is good. You just need the right supplements for your particular genes, and you're just going to be the best person you could ever possibly be. It's a little bit that way. But life is not that simple. You look for the bigger things, and really the only thing there's that much research around is around what I've just told you about, the methylation and the 3 or 4 enzymes that are problematic. The genes for these enzymes are problematic, but they can be addressed. So once you back away from this particular intersection, the MTHFR, methionine synthase, and the cystathione beta synthase, otherwise known as CBS, once you back away from those 3, the research isn't as strong for any other particular intersection. So whether we're talking about neurotransmitters, but this can go, methylation has a lot to do with neurotransmitters being turned on and off, and you can go much farther with this. So as this next underlying aspect, I started with the rather depressing topic of, hey, it's a high rate of suicide that's been happening in the pandemic. And there's been a high rate of women's suicide and suicide in general in Japan, and they always have had that. There's ways of treating that to intervene. And so I gave you the whole ketone thing. And now we're looking at the most common, now well-documented. Let me show you a few other studies that you'll find interesting. Just the titles of. I don't have to go into great length. Here's one. How folate and a genetic mutation can impact your depression risk. MTHFR, methylene tetrahydrofolate reductase. They put it all in the title to make it seem pretty erudite. MTHFR in psychiatric diseases, and that's in 2018, and that's in translational psychiatry. We have MTHFR screening and treatment-resistant depression. So finally, some places, and where was that? That was in 2019. So just less than 2 years ago. It says therapeutic response to antidepressant drugs is often partial. The problem is, by the way, if you find somebody that has these genes, or they didn't know they had these particular problems, and they went on antidepressants, they would probably get worse because they're not treating the problem. You've just now amped up one side of the equation for them. So it really needs to be looked at. So one of the things that in terms of a regular metabolic lab, now we're not talking about genomes, you really do need to look at things like homocysteine. Homocysteine is a natural part. I mean, you do need to have a level of that. But usually if you find really elevated homocysteine, something's being blocked. It's not being converted back into methionine. It's very fascinating, and it goes through a lot of half steps, which are equally important in terms of emotional stability. So you really need to do blood work. You need to do some genetic profiling, if you will, to look for nutrient deficiencies. And I do hormonal because people can relate to hormones, and that goes into other neurotransmitters as well. That is something so important, and I just assume this should be the standard of medicine today. I do get angry at these knockoffs. Nobody went to medical school, and suddenly they'll say, yeah, you get your gene stack, you take my supplements, and I will make your life fine. Well, they took that partial truth. They don't know how to differentiate whether their thing is working or not. They want you to buy their stuff. And that's usually what happens with these companies that now have invested into testing your genes, right? So you do a tube and you spit into the tube, send it in, and they look for these polymorphisms. You get your report. But their upsell, if you will, their upsell is to sell you their brand of supplements because they've matched it specifically to these particular polymorphisms. And they'll name out 85 and saying, these are the ones you should take. I wouldn't go that far. Their information is not that well known. There's a lot of really interesting stories associated with various enzymes and the genetic problems that people have with some enzymes and therefore the problems that are caused. But life is much more multifactorial. It's about what you eat. It's about what you're exposed to and the problems that is. So you need to also think of a level of cleansing. We bioaccumulate garbage. 2003, the FDA had a report that showed that every fish in the United States in streams and ponds had heavy mercury. That doesn't mean they checked every fish. It means they checked, I guess, every pond and every stream and then took obviously a consensus of that. That means the good old days of fishing with your father and mother and uncle and aunt and, going back with your campfire is not such a great idea because they're heavy mercury. Now, where did that come from? That's a whole different wormhole, as they say, that goes off to primarily coal-burning plants. So that has to be taken into consideration. Most people don't want to go there. It's like, you've already stressed me out. You said now there's 4 things I'm supposed to be doing, and now I have this environmental thing. It's like, that's it. I got to go back to eating donuts. Forget about what you said. I don't want to pile it up that much, but I'm saying, I'm begging for your intelligence here. I'm begging for your ability to hold more information than just one simple thing in your mind that, hey, there are some ways to look at this that are not that complicated, that do logically go together, and then saying, this is it. This is what we can do. Nothing is 100%, but they've really improved the situation if you look at these things. So with that, I'm going to say, we'll bring this to the end because now you heard some studies. I think we'll just go over the whole intersection of methylation. If I was to throw it out there to go further, 2 other genes that are fairly well supported, not as well as what we just talked about, are COMT, MAO. And so you all know about MAOs because you've heard about MAO inhibitors. They're just like serotonin reuptake inhibitors. Those are antidepressants. It's one of those genes that the big pharma has been looking at for a while as well. But working with, does this person have a particular polymorphism that either slows down the transformation of certain neurotransmitters or speeds it up so quickly and then it disappears? So these are the things you have to look at as a start for this larger collective. I hope I didn't overwhelm you. I find this intensely interesting. And each person, when they come in, we get this data, it's unraveling the story of their life. And usually the people that come to me or work with me, I would say as an average age or in their 50s or late 40s, or they have some real issue earlier on they want to get looked at. It's not just another doctor call. It's, this isn't working. I need to find out. Let's do a deeper dive to understand what's going on with me. Take care. Dr. Goldcamp signing out. Hi, this is Dr. Goldcamp. I just wanted to encourage you to send in your questions to drgoldcamp@ketonaturopath.com. Many of you have, and so what I've done with these questions that I've gotten back to most of the people I email, but some of the questions that were so good, and if they were overlapping to other questions, I would combine them and try to put that into the topic of a podcast, either via one of the micro topics that are covered in an interview. As you know, we cover a lot of topics in any given interview, or some of my own sort of reporting, if you will, on some of these issues. So please keep the questions coming. Feel free to send in an email, and I will get back to you. Stay listening, send in your questions, and I will definitely get back to you.